Okay, so here is the progress on my CNC build. I got several different parts to get to this point. So I have the linear rails that came with the ball screw. So that's a set. And all I did was I 3D printed some, plates to bolt onto here just to keep the blocks and the, I'm not sure what it's called, the ball screw nut, I think, together as if it were together as a bed, right? So then that can move as a unit. I guess I'll show you a little bit later. And then I got, this is a closed loop NEMA 34 stepper motor, and I had to get the little attachment there. And then I have a power supply, which is rated for the motor, of course, which is the upper end of what it allows. So it's 60 volts DC, which is kind of scary, so I have to be really careful there. And then that runs into my motor stepper motor driver here that came with the motor. And so this is, of course I have it off, this is the DC coming in, these are my motor leads, and then these are the encoder leads that come from, so the encoder is on the motor, the stepper motor, and then they come in here, feed the data to this driver, which corrects for any errors. So that, with stepper motors, the issue is that it can lose steps. If it goes under too much load, it can lose steps, and there's no data for the computer or anything to know that it's off. So the benefit of closed loop stepper then is that this will know that it got off and lost some steps, and then it will correct, and it will keep going until it finds those steps again. So that's the data cable there. And then this is, of course, going to the Arduino. So this is step size and direction. So, that goes into my Arduino Mega that I have here. I got a Mega so that I can cover all the inputs and outputs for a CNC machine, 3 or 4 axes, and then, all the limit switches and yada yada, all that. Right now, I just have a test sketch on it to run, so I can just go forward and reverse on the motor. So that's it. So let me show you this setup in action. This is, of course, just a demonstration. I'm not going to have the rails so close together as this. I want them wider for more stability. But the main goal here is to create a CNC machine that is small enough to fit into a small living space. There are some CNC machines out there that are not what I was looking for. They are small, but they are very flimsy. So not this. They supposedly can cut metal, but the best they can do is aluminum, so far as I can tell. And I'm wanting to do way more than aluminum. So I've got the full size. These are full size motors. No compromise on that. And also the rails are very hefty. They're not small at all. So and it's just to tie it together. So I'm going to demonstrate this in action. The 5 volts goes to the Arduino, and then this goes to the power supply. So those are our power inputs. So let me turn this on. And you can see that turns on the power supply, and now I'm going to be very careful not to touch anything with the 60 volts. So that's all powered on and ready to go. So here's my buttons. Like that. And this thing is ridiculously strong. Like, I have not been able to make it miss a step yet. So I know this isn't a super impressive demonstration, but I can crush this. It just, no resistance, no hesitation on that. So I'm definitely going to have a lot of safety systems. There's ways to make it so that If you hit E-stop, it doesn't come back on again, and you've got E-stop, got limit switches, stuff like that. So I'm gonna put wire in, hard wire, not software safety stuff that bypasses the computer entirely, so that if something fails, it stops from relays. Another thing here, so I printed this. This is just a test piece to put these together. So you can see this piece is here, so it just bolts in there and then bolts there, and that's just a tied together piece to make it, hold it together. So it's kind of just a bracket to temporarily hold it. This is my, grease gun to grease all the ways, and the ball screw. I'm going to show you then the next steps. So like I said, this bracket is temporary just to test the linear rails and the motor setup. But what I want to do eventually is to build a concrete base for this. I'm going to try just quickly to get started. It's probably not going to be strong enough, but I just wanted to try it for see if it would be good enough. And the idea of building a CNC machine with concrete is that it will absorb vibration and anchor it very well. So and it just makes it a lot quieter and a lot more sturdy. Because sometimes people will build, a lot of times people will build a hobby CNC build using extruded aluminum rails, and those are like a bell. They resonate and they're loud and they don't absorb vibration. So I'm gonna go with concrete for those reasons. Keep it quiet and accurate. Supposedly you can make a CNC machine as accurate as a professional purchased CNC machine if you use concrete or epoxy granite, they call it. It's like a mixture of sand or even granite pieces that are mixed with epoxy. I'm not going to do that just yet because that's actually a very expensive way to build it. So I'm going to try. A lot of people can get away with just not Quikrete, but standard concrete, but that takes weeks to cure. So for a quick test, I'm getting cheap $7 bag of concrete, and I will just make this for now, and then if they break, then I will replace them with the higher quality pieces. So I have this chicken, it's like whatever, rabbit wire welded, and I'm going to use that. The real concrete wire is so expensive. It's $20 for a roll, and I don't think it was even going to be enough. But this for sure, I will probably show you later when I'm actually casting this. Most people make the whole base as one piece, and it just sounded extremely daunting trying to get all the holes and everything set up and getting it level. And so I decided to do it almost like railroad ties. I don't know if that's going to work, but the idea is, well, this thing's accurate. So rather than having a piece that I will bolt it down to and it could get out of whack, I will put them from the bottom and bolt them up onto it, if that makes sense. I'm not an engineer. I don't know if that's going to work, but I'm going to give it a shot and see. So here is a prototype that I 3D printed of half of one of them. So this is an example. The only difference is I changed my mind after printing this, that these, I want them to be on the bottom so that these don't fill up with coolant or chips. And so that's where you can put in nuts for these large bolts to bolt on a side panel. So I switched these to the bottom so that nothing will get caught in there, and it kind of just makes sense to have the hole on the bottom anyway. This is the bolt hole for these bolts. So I will get, nut goes in there, bolt goes there, and it bolts it down. So these will line up underneath like almost like railroad ties. So it'll go like that, and they will all line up, and hopefully it will provide the rigidity. I'm gonna have a side piece. This is clearance for the ball screw, So that's the positive of it. And I will show you this. This was quite the project to make a mold to cast the concrete. So let me make those disappear and that. So this is, you know, the outer wall for the mold, and then I got, you know, I had to design the negative space for each of these, like the bolt holes and everything. So, you know, that's negative space, right? And that, I had to make it all fit together, make all the holes for the screws. I made it so this can bolt together up here. And you know, a mold obviously is the negative space around what you're hoping to make. So where is that? Oh, here. Yeah, so you know, first I designed, there's the printed part, you know, the part that I already printed to demonstrate, made that, and then had to make the negative or the mold around it. And that was a lot of work. And then making the, if I can find it here, the lids for it, right? Or the side covers. Make that go away. So that goes, and I'll show you the real life of this too. But that was, you know, I had to design it all digitally first and then make my negative space pieces there. And here it is in real life. So you can see there's the outside pieces, and I didn't have bolts that were small and long enough. So these screws worked out because they're, you know, the top part is smooth. And then on the bottom, or whatever, the other side, there's these bolts that worked. And then these panels go on. I've got all these, they're just wood screws. Nothing fancy. And, you know, obviously tightened down really tight. And then these are the negatives of my bolt holes to be able to put bolts through. You know, I can't drill into concrete, obviously, so I created these negatives. And so here's this, that goes in there and creates, you know, the negative, that, right? And so that then screws in like that. And then afterwards I can take the screws out. You know, I'll take the whole mold off once it's cast and cured. Take the whole mold off. There will be another one here. And then these I could, like, you know, drill out, chip out, whatever. And then that will provide the holes where they're supposed to go, right? So, you know, picture this concrete and it's like that, right? So, I will put the metal mesh, cut it to fit, and then pour concrete in, close up the top, flip it up, and vibrate it all, make sure it's settled well, and then top it off through these holes, and then wait for it to cure. Those stripped out so that that won't interfere with the next step. Just a little bit, and then this side too. that's all we need right there. You can see that's pretty solid. That's not quite seated. Here we go. Okay. And one last one here. Just like that. So there we've got our 2 bolt holes ready to go. Okay, so this first cast was a fail. My mistake was that I cast it in this orientation, and so it was, not completely full, and this stuff sets up really quick. And so I tried to turn it and, bump it. I found that kind of dropping it a little bit made it settle really well, but in the amount of time it took me to put the cover on and then turn it and try to settle it there, it had already set up to the point where it couldn't get all the way to the edge. So some of it did, and you can see it's a very nice clean edge. It covered the wire mesh just fine. You've got crisp corners, no major bubbles, but I definitely have to cast it in the finished orientation, which is upside down, from the beginning. And then I think that should do it. That will get it to be a nice cast. So, lesson learned, and I was kind of expecting the first one to go wrong in some way, and I'll learn from that and do another cast. There it is, got the mold off, and here, it's not fully cured, but it's set up enough to where I can take it out. So there's the idea, and this is acceptable. A little bit of a bubble there, but otherwise this is perfectly within the parameters that I'm looking for. And so I would just drill out these plastic parts and it'll be good to go. Alright, this is my next attempt. So this time I kept it in that end orientation so that it would settle correctly the first time and I wouldn't be turning it then after it was set. You can see, I added it through those holes and it's very messy, which gives me an idea that I could put some sort of like hoppers on the top, because that, when I was knocking it and it was settling, it kept dropping below the top there, which made me think that some hoppers would be a good next move to have more material ready to go. So I think that's my next step, but we'll see how this one turned out. This is attempt number 2, and I'm just waiting for it to set up so that I can take it apart and take a look at it. Alright, here's the result of attempt number 2. You can see major gap right there. So I'm going to really have to come up with, I'm going to have to go back to the drawing board and come up with a way to make this mold with the entire bottom open so that that doesn't happen again. And also that whole gap, that's trying to basically fill like a cave from underneath, which really is not going to work. I have to be able to have an open top mold and fill it from the top of the mold and not trying to scoot it around the back. So, yep, it's back to the drawing board. I'm going to have to redo this majorly. Alright, so this is my 2 attempts. This is the reality of trying to make your own thing without anybody doing it before in the exact way that you're trying to do it. You know, it's not a kit. I'm not following instructions, so I have to come up with the right way to do this, and it's pretty difficult. So I'm just going to keep trying, and I think that's enough for one video, so I will make the next video with the next steps that I take on this. So see you in that video.